Hello everyone. The title of this video is Finding the Domain and Range of a Quadratic Function. Now every example I'm going to be doing in this video is taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry text, section 5.1 called Quadratic Functions, and I'm under this heading, Finding the Domain and Range of a Quadratic Function. Alright, so as I said, each example is going to be either an example from the reading or one of the try it problems you see throughout the reading, or one of the exercises at the end of the section that's related to this particular objective. Alright, so I hope you watched previous videos of mine covering some stuff from section 5.1 of this OpenStax Algebra and Trigonometry text. So I talked about, finding the vertex and the axis of symmetry and the intercepts of a parabola, right, the graph of a quadratic function. So this is just stating the domain and the range. All right, so I'm going to tell you right now, the domain for any quadratic function. Remember, the domain is all the inputs, right? The set of all the inputs, the set of all the x coordinates, all the values I can plug in for x. Well, in every single one of these quadratic functions, there's no denominators with variables. There's no square roots, fourth roots, no even roots, no logarithms. So I can plug in anything I want for x. The input can be anything. So the domain is all real numbers, every value from negative infinity to infinity. I can plug in anything I want. Again, you can say all real numbers. If they want interval notation, right, you go negative infinity to infinity with the parentheses. This is all real numbers. And as I said, this is the case for any quadratic function. It's the range that you have to pay attention to. Alright, so for any quadratic function, domain's all real numbers. Now to determine the range, you just need to know the vertex and which way the parabola is opening. So here we're asked to determine the domain and range. Again, I said domain's all real numbers. We have, number one, f of x equals negative 2 times the quantity x plus 3 squared minus 6. Now this equation here is in that vertex form or standard form that I talked about in my last video. That's earlier in the section, where it's, f of x or y equals a times the quantity x minus h squared plus k, and the vertex had coordinates hk, right? Thus the name vertex form, right? You can very easily determine the vertex. So in this form here, right, this particular polynomial, this particular quadratic function, the vertex is negative 3, negative 6. Negative 3 would be h, right, because it's x plus 3. That'd be x minus negative 3. So h is negative 3. And then plus k plus negative 6. All right, and I'll start making a rough sketch here. All right, negative 3 for the x, negative 6 for the y. There's the vertex. And then a is negative. All right, the lead coefficient of this quadratic function is negative. And if, again, you recall from the last video I put out on this, if that lead coefficient is negative, the parabola is going to open down. And that's all I really need to make a very, very rough sketch of this parabola. The vertex is at -3, -6, and it's going to be opening down. Right? I don't know exactly how. It should be symmetrical about x equals 3, but again, very rough. So do you see the range is all the values on the y-axis, all the outputs, from -6 downward. But if you're writing in interval notation, remember you go from bottom up. So the range for this particular problem is all the values from -infinity on the y-axis, up until -6. Always parentheses on the infinities, right? They're not numbers. And -6 is the output, right? That is the y-coordinate for 1 point. So it is used, you put a bracket, right? -6 is included in the range. If it wasn't, you'd put a parentheses. But yeah, so that's it. Here's our what they want from this number 1, from this example. Okay, so really you just got to pay attention to where's the vertex and which way does it open. Right, if you know the vertex and the way the parabola opens, up or down, you should easily be able to state the range. Right. And again, the domain is all real numbers. You can plug in any value for the input you wish for these quadratic functions. All right, next example. All right, now this one, this is in that general form, right? Not standard form, not the vertex form. This is in that y equals, or f of x equals ax squared plus bx plus c. And again, I discussed this also in the last video. Here, the vertex can be found easily. The x coordinate, if you're in this general form, is -b over 2a. That'll be the x coordinate of the vertex, or where the axis of symmetry is at. Right? X equals -b over 2a. And then you just plug it in, and get f of -b over 2a, and that's the y coordinate. And once again, the lead coefficient will tell you if it's opening up or down. All right, if it opens up, a is positive, and opening down, a is negative. All right, so here, a is 2, and b is the -4 there. A is positive, so I know it's got to be opening up. All right, the parabola is going to be opening up. I just want the vertex. So x equals -b over 2a, which would be the opposite of -4 divided by 2 times 2. That's +4 divided by +4. So x equals 1. Right? There's the x coordinate of the vertex. And then what about the y coordinate? Well, what's f of 1? Just plug in 1 for x. That's 2 times 1 squared minus 4 times 1 plus 2. This is just 2 minus 4 is -2 plus 2 is 0. Right. Yeah, 2 minus 4 plus 2 is 0. So the vertex for this parabola is 1 for the x, 0 for the y. Again, I'll draw a tiny sketch over here, 1, 0. On the x-axis, that's where the vertex is. And we know it opens up. So again, I'm just going to do a very, very, very rough sketch of this. There you go. It'll cross the y-axis at 0, 2 if you want to put that in, but I don't really care where the intercepts are. I just want to know where the vertex is and which way it opens. The domain of this function, again, the domain for all these quadratic functions is all real numbers. You can plug in whatever you want for x. The range, however, is not all real numbers, right? The range, going low to high on the y-axis, the lowest y-coordinate is 0, and then it goes up. All the y-coordinates above 0 are used in this graph. So from 0 to infinity, right, including 0, and then always parentheses on infinity, and there you go. This is what they wanted, right? What's the domain and range of that function? Easy, 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 in my opinion. Okay, and then my last page just got a couple more of these because these are all pretty simple. Again, these are exercises taken directly from the OpenStax book. related to this objective. Vertex is 1, -2. And it opens up. What's the domain and range of a quadratic function like that? Well, again, the domain, all real numbers. The range, though, be from -2 and up. Right? -2 is the lowest y coordinate being used, and everything above it is used. So from -2 to infinity, bracket on -2 and parentheses on infinity, and there you go. Very, very easy. And the final example I'm doing in this video, very short one this time. Vertex is -5, 11. So in quadrant 2 here, and it opens down. Again, I don't know how it opens down, how wide it is, how narrow it is. I just know that it opens down. That's all I need to know. What would be the domain and the range for such a function? Domain is all real numbers, right? This is the case for any quadratic function. The range, though, is all the values below 11, up until 11, including 11, and nothing above 11. So from -infinity up to 11. And again, a bracket on 11, because 11 actually is the y-coordinate of that vertex point. And there you go. Very, very simple. So to state the domain and range of a quadratic function, just find the vertex and figure out which way it opens, and you should have no problem stating the range. Great, and I'm hoping that watching me go over these 4 examples here helps you in some way when you're asked to state the domain and range of a quadratic function on your own. Thank you very much for watching.